And finally, solving logarithmic equations. So let's start with an example. The Richter scale magnitude R of an earthquake is determined using the following formula. R equals log A divided by T plus B, where A is the amplitude of the vertical ground motion in microns, T is the period of the seismic wave in seconds, and B is a factor that accounts for the weakening of the seismic waves. An earthquake measured 5.5 on the Richter scale, and the period of the seismic wave was 1.8 seconds. If B equals 3.2, what is the amplitude A of the vertical ground motion? So first, let's identify what variables we have. We have the magnitude of the earthquake, or R, which equals 5.5. We have the period of the seismic wave, which is 1.8 seconds. And we have the factor B, which is equal to 3.2. So we want to solve the following equation. 5.5 equals log of A divided by 1.8 plus 3.2. So same as solving exponentials, we need to try to get one term on each side. Right now we have two terms on the right side. And we can fix that by minusing 3.2 from both sides. And now we have that 2.3 is equal to the log of A divided by 1.8. To solve for A, since it's inside of a logarithm, we need to change this into an exponential. So use the inverse. We end up with our argument A over 1.8 is equal to, this is a logarithm of base 10 and the exponent is 2.3. And then our final step to solve for A is to multiply both sides by 1.8. So we end up with A is equal to 1.8 times 10 to the exponent of 2.3. And using your calculator, you should get that the amplitude of the seismic waves are approximately 359 microns. Next, we're going to look at solving different types of logarithmic equations. So A, log base x 0.04 equals 5. Since we have one term on each side, let's convert this to an exponent. So we know our base is x, so we have x to the exponent 5 is equal to 0.04. In order to solve for x, we're going to need to take the fifth root of each side. So therefore, x is equal to the fifth root of 0.04. And if you use your calculator, you get that x is approximately equal to 0.525. Next one. Notice in this one we have a logarithm on both sides. So since they're both the same base, all we have to do is equate what's inside each logarithm. So we get 3x minus 5 is equal to 16. And then we can solve. We have 3x is equal to 21, and therefore x is equal to 7. And of course you can verify by subbing x back in to the expression and check that the left side equals the right side. C. Notice we have two terms on one side, and again, to solve logarithmic or exponential equations, we need to try to get one term on each side. So to bring these two terms together, we're going to use the product rule. Remember, the product rule for logarithms states that if we have addition, we multiply the inside of each. So we have x times x squared, and that's equal to 12. So we have the log of x cubed is equal to 12. I would now use the power rule. So that means we can bring the 3 to the front of our logarithm, and we get 3 log x is equal to 12, which tells us that log of x is equal to 4 if we divide both sides by 3. And now I would convert to an exponent. So we have 10 to the exponent 4, and that should equal x. So therefore x is equal to 10,000. So important step here, when we get to this point, we need to rewrite as an exponent. And of course, you can sub this back into the left side and check your work. And our last example. Again, we need to get one term on each side. Right side is good. The left side, we need to bring these together. And since we have the same base, we're going to get log base 2 of x plus 3 times x minus 3. And that all equals 4. So let's expand that quadratic. We get log base 2, x squared minus 9 is equal to 4. Next, I would change this to an exponent. We get that x squared minus 9 is equal to 2 to the exponent of 4. 2 to the exponent of 4 is 16, plus the 9 gives that x squared is equal to 25, and therefore x is equal to plus or minus 5. So again, our steps. First step was to use our product rule. Then we expanded the expression. Next, convert to an exponent. And then solve for x. However, note, x equals minus 5 is not a solution. Can you figure out why? If you try to verify the original equation, if we want to verify the left side, we get log base 2 of negative 5 plus 3 plus log base 2 of negative 5 minus 3. So we have to evaluate log base 2 of negative 2 plus log base 2 of negative 8. And recall that the domain of a logarithmic function is that we can only have inputs that are positive. And notice for both, we have negative inputs. So therefore, x equals negative 5 is not a solution to this equation. And therefore, x equals 5 is a solution to this equation. Try out the following questions.